Hi, grade 10s. Let's do this geometry question. It reads ABCD is a parallelogram where AC is a diagonal. Okay, so ABCD is a parallelogram. So let's highlight A to B to C to D and back to A. Okay, so that is a parallelogram and AC is a diagonal. And then it says with A, F, E, and C as collinear points. So A, F, E, and C, they are collinear. So they are on the same straight line. Okay, let's start with the question. 8.1 says prove that triangle ABE is congruent. So that's congruency, eh? Is congruent with triangle CDF. So the first thing you do, let's quickly just highlight those two triangles. So ABE, so this is triangle ABE. Let's highlight triangle ABE and triangle CD. There are four ways to prove congruency. So in these two triangles, let's just first look for any sides that are equal or any angles that are equal. And remember, you start with the information that was given. So it was given that ABCD is a parallelogram. So we know that with the opposite sides, they are equal to each other. So those opposite sides are equal to each other. So when you look at this, do you agree that this is equal to that? Opposite sides of a, so there I have two sides that are equal already. In this triangle, AB is equal to CD in the other triangle. So let's write that down. In triangle ABE and triangle CDF, AB is equal to CD. Opposite. So that's opposite sides of a parallelogram. This is a, they are equal. Okay, so that's the first thing. So that is equal. Okay, so because this is a, we know that this is parallel to this. And so if you look at this, you see if these two lines are parallel, then this angle is equal to that angle, alternating angles. So let's see if I see something like that. This is parallel, this is parallel. There's the transversal, so there's the line connecting the parallel lines. So do you agree that this is equal to that alternating angle? A1 is in the yellow triangle and C is in the blue triangle. So let's write A1 is equal to C2. Alt angles and the lines that are parallel, AB is parallel to CD. So let's make it X. So this is equal to that. Okay, now we need one more thing. It's either a side or it is a angle. Okay, so do you notice here, grade 10s? Here it's given that this line is parallel to this line. Both of them have one arrow. So there I see another Z. You see, this will be equal to that alternating angle. So look here, there's the Z. So that means E1 is equal to F1 in the other triangle. So I'm going to write here, in the yellow triangle, E1 is equal to F1 in the blue triangle. And the reason is the same. Alt angles, but the lines that were parallel here is BE is parallel to FD. Okay, so there I have three things. This was a side, this was an angle, and this was an angle. So I'm going to say, therefore, triangle ABE is congruent to triangle CDF, and my reason is angle, angle, and side. Okay, so that's for 4 marks, eh? So 1, 2, 3, and for this reason here, you get 4 marks. Now, grade 10, remember, if triangles are congruent, the angles are all the same, eh? So, if triangle ABE is congruent with triangle CDF, then angle A is equal to angle C. So, do you see the A is equal to C? Because of congruency, B is equal to D. So, you see this B over here, that B is equal to this D because they are congruent. And then E is equal to F. So this E, let's make it Y, is equal to this F over there. Okay, but that was proven. I'm just going to fill it in because now we have just proven that the triangles are congruent. So maybe in the next question, I might have to use the fact that those angles are equal. Let's look at our next question. 8.1.2 says, prove that angle CEB. So prove that angle CEB. Let's go look. Where is CEB? So angle C, then to E, then to B. So that angle is there. So this is angle CEB. Prove that that angle is equal to AFD. So A to F to D. So it's this angle there. So prove that those two angles are equal. So if you have two angles on a straight line, if this angle is y, then this angle is 180 minus y. Angles on a straight line. If you don't understand that, let me give this angle a label. Let's say this was angle B1. So y plus angle B1 is 180 because of angles on a straight line. So you would say y plus angle B1 is 180 angles on a straight line, eh? Then you would say B1 is equal to 180, then you take the y over minus y. So B1 is 180 minus y. Angles on a straight line. Do you see that F1 and F2 are angles on a straight line? They are angles on a straight line. So F2 is 180 minus y. Because F1 is already y. So if you take that out, this is y. That means this one is 180 minus y. So F2 is 180 minus y. Angles on a straight line. Then, do you see that E1 and 2, they are also on a straight line? E2 is 180 minus y. Angles on a straight line. And there I proved it. Therefore, F2 is equal to E2. Because remember, I had to prove that this is equal to that. So therefore, F2 is equal to E2. And you can make the angles y, eh? And grade 10, if you want to start with saying this is y and this is y, E1 is the same as F1. Why? Because of congruent triangles, okay? I explained this before, but if you want to write this out, you can start like this, eh? Then you say, let's make E1 and F1, because they are equal, let's make it y. So then you start. And then from there, you go into that. Okay, so now we prove that those two angles are the same, eh? So I'm going to make this 180 minus y. And this one is also 180 minus y. Okay, next question says 8.1.3. Prove that AF is equal to CE. So AF is equal to CE. AF is here. Prove that that side is exactly the same length as CE. So CE is over there. So we need to prove that they are the same. So let's see, what can we do here? Okay, so to prove that sides are equal, you can use congruency, eh? So I'm going to prove congruency in triangle. So I want FA to be in the triangle. So let's use a lighter color. So I'm going to use this one. So that triangle over there. And I want CE to be in a triangle. So let's use that triangle over there. Okay, so now I'm going to start there. Let's write 8.1.3. So the bottom triangle here, let's use that one, FAD. And triangle BCE. So BCE. Let's see if we can prove congruency. So this is a palm. Do you remember? This is a palm. So if this is a palm, this side is equal to that side. So I'm going to write that down. AD in the bottom triangle is equal to BC on top. Opposite sides of a palm are equal. Then remember this F2 in the bottom triangle is equal to E2 on top. We proved it here in that question. Here you can just say proven. Okay, so we have that. Then this line is parallel to that line. So I see a Z. Do you see the Z? There's the Z. So that means C1 is equal to B2 because of alternating angles. Then I'm going to write that down. So in the bottom triangle, A2 is equal to the top C1. And that is alt angles. And the lines that are parallel is BC is parallel to AD. Okay? So this was a side, this was an angle, that was an angle. So then I'm going to say, therefore, triangle. So now I'm going to go with the angles, eh? This was an angle, this was an angle. So A, F, and then only D is then left. So that the order is right. Therefore, triangle A, F, then D is left, is congruent. Then I go, A went with C. So to triangle C, then E, and then what's left? I used C, I used E. What's left is B. And then the reason is angle, angle, side. Angle, angle, side. Okay. When triangles are congruent, their angles are the same and their sides. Here we had to prove a side, so I'm going to look for sides, eh? Do you see AF is the first two letters and CE is the first two letters? So therefore AF is equal to CE. Why? Because of congruent triangles. And that's how you prove that. Is question 9 from this question paper. It says, in the diagram below, R is the midpoint of QT. So R is the midpoint of this QT. So if R is the midpoint, then this is equal to that. Then it also says S is the midpoint of PT. So S is the midpoint of this whole line. That means this is equal to that. The length of SR, so the length of this line, is 2x plus 4. And angle Q is 39 degrees. There we go. And P is 55. Okay, everything is on the diagram. Let's start. 9.1 says, determine the length of PQ in terms of X. So determine the length of PQ in terms of X. Okay, grade 10s. So when you look at this triangle, it looks like the midpoint theorem. So the midpoint theorem says if this is equal to that and this is equal to that, then this is half of this. Or you can say this is double this. Okay, so I see the midpoint here. Eh? So that means this is just upside down. It looks like this. This is equal to that. This is equal to that. So this is double this. So let's write that down, 9.1. So I'm just going to say PQ is double, so 2 times SR. Okay? Why? Because of the midpoint theorem. Then I'm going to say, so PQ is 2 times 2x plus 4. And then I'm just going to remove the brackets. I get 4x plus 8. And there you have the length of PQ in terms of x. So there's an x in the answer. And that's how you do that question. 9.2, let's go on. If the length of PQ is 18, determine the value of x. Okay, so now they say this PQ is actually 18. So I'm going to replace this part. This is now 18. 18 is the same as 4x plus 8. Let's solve for x. Keep the 4x there. 18 minus 8, 10. I get 4x. Divide both sides by the number in front of x. I get my x to be 10 over 4. Simplify to 5 over 2. And that's how you would do that question. Then the last question, 9.3, says, prove that triangle TRS. So let's highlight. Prove that triangle TRS. So that's that triangle. Prove that that triangle is similar to triangle TQP. So the small one here must be similar to the big one there. Okay. So before we start, let's fill in the missing information. So if you have a triangle where you have the midpoint theorem, what do we know? We know that this is twice this, but we also know that this line is now parallel to that line. Let me use another color. So this is parallel to that. I think that will help us, but you have to write this down now, eh? So 9.3, let's write down RS is parallel to PQ because of the midpoint theorem. Okay, so let's go. Similarity. To prove triangles are similar, you need either angle, 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 or you need to prove side, side, sides that are in proportion. So for this one, I'm going to try angle, angle, angle. So if this is 39, then this angle here is also 39. Corresponding angles. Do you see the F there? There's the F. The F looks like that. This is equal to that. Corresponding angles, eh? Then I see another pair of corresponding angles. This is equal to that. So this one is also 55. Corresponding angle. And then this T is in the yellow triangle and it is in the big triangle. So this one is common. So there I have three angles. Now I just have to write it out, eh? So I'm going to start with angle Q is equal to angle R. Both of them are 39. And the reason is corresponding angles PQ is parallel to RS. Then we have angle P is equal to angle S over there. So you write that down. P is equal to S. Both of them are 55. And the reason is corresponding angles PQ is parallel to RS. And then the last angle is this T that is common, eh? So T in the small triangle is the same T in the big triangle. We don't know the size. You can work it out if you want to. You don't have to. And it's a common angle, eh? So now, therefore, triangle, you can say it in that order. Triangle TRS is similar to triangle TQP. And then for your mark, you must write angle, angle, angle. And that's how you will get 5 marks, eh?